So hi guys, so welcome back. So today's class we want to discuss on the discrete mathematics, on where we left from last class. We've covered a number of topics, and these virtual classes will just contain the topics that we did not cover. So in discrete mathematics, today I would want us we discuss on one of the topic known as pigeonhole principle. It's one of the topic. So just allow me to start from the definitions. So in the pigeonhole principle, we are going to define two principles, principle 1 and principle 2. As you can see, there are some presentations here, mi, whereby if we want to define this one, then we can say let there be m subscript I objects and m subscript j boxes. So what we want to do is that we have boxes and we have objects, and we would want to put these objects inside the boxes. And see what we've defined here. The subscript I and j are defined under this such that I and j will take numbers from 1, 2 all the way to n. In other words, it will consider the whole cardinality of the set. Now, if m plus 1 objects are put in m boxes, then at least one box contains 2 or more objects. What we mean here is that we have more objects than boxes, and would want to put all these objects in the available boxes. Therefore, if A is average number of pigeonhole or objects per pigeonhole, then we define principle 1. Principle 1 states some pigeonhole will contain at least ceiling of A pigeons. So that means there are some pigeonhole that will contain at least ceiling of A. That means more objects. Principle 2, some other object hole will contain at most floor of pigeon. So statistically, in discrete mathematics, we define the ceiling like this. You can see this. Then we have the floor defined like this, such that if the examiner just puts something like this in the question or when you are doing your revision, so just know that this is a ceiling and this is a floor. Good. So next, I just want to give the explanation on principle 1 and 2. For instance, let there be 12 pigeons and 5 holes per se. What we want to do is this. All these pigeons must be contained in these holes. You can see that pigeons are more than we have the holes. Then 12 divided by 5 will be 2. So this means that we will have some holes, pigeon holes, that will contain more than 2. This is 2 point something. It will contain more than 2. This means that some holes will actually contain at least 3 pigeons, and some other holes will contain at most 2 pigeons. What this means, if this was 2.5, of course we have pigeons which we cannot divide them, so we have to take the whole number, and therefore some hole will contain at least 3 pigeons, others will contain at most 2 pigeons. Let's define the theorem so that I will explain the examples later. There is a theorem, and this states that there are n pigeon hole, then the minimum number of pigeon required to guarantee that some pigeon contain at least k plus 1 pigeon is kn, that is k times n plus 1. So this just a proof, theorem that we can prove it. And here we've proved this theorem, which states that if we have n pigeon hole, then the minimum number of pigeon required to guarantee that some pigeon contains at least k plus 1 pigeon is kn plus 1. The proof is direct here. What we are doing is that we are taking this second part of the theorem, you divide by n, because you would want to eliminate this n here. So if you divide by n the whole of this is the whole of the numerator, you divide by n becomes the denominator, then you separate these two terms, which is very true. So it will be kn divided by n plus 1 over n. If you cancel this n and this, you remain with k plus the second term here will be a fraction, that is 1 over n. This means that there are some fraction given by 1 over n, because now k is a whole number and we are adding another fraction here, which is 1 over n. Then you need to note that k plus something, k plus something, in this case it's 1 over n, it's a fraction, but we are adding something here, will always give you k plus 1. Reason being, we do not want to count half an object or 3/4, we just want to count it as a whole. So this something here will be given as 1. This is used to explain the principle, the one that we've discussed up here. This one here, that some pigeonhole will contain at least ceiling of A pigeons. Example, the registered students in a university are 401. These students are supposed to be distributed to 50 available classrooms. If we take this 41 to be the number of students in the university, and we only have 50 available classrooms, assuming that these 401 students are doing one course, like the way you are doing discrete mathematics, and we want to divide you into 50 available classrooms, then how do we do this problem, or how do you solve this problem if you are the university timetabler? Then you use what we call the pigeonhole principle. The solution here is that we would want to divide this number of students by the available number of classes. So it will be divide for 1 by 50, and this one will give 8 point something. 8 point something. Remember, when we are proving, we had actually dealt with this something, of which is just a fraction that will be given here, which will be taken as 1, as a whole number. This means that some classes will receive at least 9 students, at least 9 students. That means 9 or more students. That is principle 1. And some other classes will receive at most 8 students. That's less or equal to 8 students. That is principle 2. Example 2, a man hiked for 10 hours and covered a total distance of 45 miles. It is known that he hiked 6 miles in the first hour and only 3 miles in the last hour. Show that he must have hiked at least 9 miles within a certain period of 2 consecutive hours. Now, this is a lengthy question, and as usual, and I will remind you that it's good to get to know the spirit of the question before you answer. So this is a man hiking, and the question states clearly that this man hiked for 10 hours and covered a total distance of 45 miles. It is known that he hiked 6 miles. So this one is a prior knowledge. It is known that he hiked 6 miles in the first hour and only 3 miles in the last hour. Then show that he must have hiked at least 9 miles within a certain period of 2 consecutive hours. Good. So another solution, if you can let A1, A2, all the way to A10 miles he hiked, A subscript I is equals to the number of miles he hiked in the ith hour. If we can define this I in the interval of 1 to 10, this means that I must be greater or equal to 1 and I must be less or equal to 10 from the definition. A subscript 1 is equals to 6. This is now analyzing the equation because we are told it is known that he hiked 6 miles in the first hour. And A10 is equals to 3. This was the last hour because from the question we are told that and only 3 miles in the last hour. So we have defined the first hour and the last hour. So we have these 6 miles and 3 miles. Suppose that he has not hiked 9 miles or more in any 2 consecutive hours, then the computation will be A subscript 1 plus A subscript 2 will be less than 9 defined on the equation. Then A2 plus A3 is less than 9. The reason why we are just settling with only 2 hours here or miles is because the question or the spirit of the question just requires you to dwell on 2 consecutive hours. And therefore, this process will continue. You see what is happening? It's just a series of numbers, A1 plus A2, A2 plus A3, A3 plus A4, all the way until we exhaust all these miles. So adding the above, you will get A1 plus 2A2 plus A9 into bracket plus A10 is less than 81. What we are doing is that if you check on this, let me just take you up here. If you check on this, A1 is appearing once in the series of these combinations here, and A10 is appearing once. You see, this shows that the process continues because in the first equation or inequality, A1 plus A2 is less than 9. A2 is being repeated plus A3. A3 will also be repeated plus A4. A4 will be repeated all the way to A8 plus A subscript 9. So A subscript 9 is also repeated on the last equation. And therefore, A2 and all the way to A9, they are recorded twice. And A1 and A10 are recorded once. And how many equations do we have here? There are 9 of them, and therefore on the right side we'll have 9 times 9 to get 81. That's what we are getting on the last part here, that A1 plus 2 into bracket A2 plus A9 plus A10 is less than 81. We know A1 plus A10 is equals to 9. Is that true? Yes, because from the first part of the solution, this one was defined in the question, A1 and A10 as 3 and 9 as 6. So the sum of these 3 and 6 is 9. That's simple. So then we want to define this. You see, we've just defined AI, I is equals to 1 all the way to 9. All the way to 9 is here. Then you multiply this summation by 2. Actually, this is a summation sign. If you have forgotten, this is a summation sign. And what it means, you take 2, you multiply by a subscript I, but this I will run from 2, not even 1, because 1 is given. So it will run from 2 all the way to 9. Must be less than 90. Why? Must be less than 90 because subtracted the 2. Then this means that if you divide the left side by 2 and the right side by 2, you will have summation of AI from I is equals to 2 to 9 is less than 45. That's a simple computation because you're just dividing 90 by 2. Well, before we go to the exercise, if you have any question on what we've discussed on the pigeonhole principle, please record your question on the discussion forum. You can also use my contact. It's attached in Masomo. I have my email there and my phone number. You can just inquire more. So this is the exercise that you're supposed to do. And it is good that you go through this question, each and every these questions, know what it is asking, and then do your computation, because it will help you in your revision for your cuts and your exams. So guys, thank you very much. So if you have a question, please contact me, discuss in the discussion forum, or email me. Next, I'll be taking you through permutation and combination, and later we shall finish our unit by looking at the proofs, theorems, which we've not covered. So thank you very much, and enjoy your day. Thank you.